This is the world's shortest database course. I have condensed the insight from 4 classic books and a decade of personal experience into just a few minutes to give you all the core concepts of databases. And whether you are new or a seasoned developer looking for a quick refresher, this video is for you. Understanding these foundational ideas will put you ahead of most developers. While many focus on learning specific tools or technologies, they often skip the most important part, the why behind databases. With a solid grasp of these concepts, you'll be better equipped to choose the right database for your needs while understanding the trade-offs and challenges that come with each option. The best way to understand a technical solution is to first understand the problem it solves. Databases address 2 universal human challenges: how to store information and how to retrieve it. But guess what? Every single human being already has such a technology, and it's called the brain. Your brain is an amazing storage device, but it has limitations. You can easily forget things, and sharing what's in your head is not easy. We've invented ways to take data out of our brains and put it into a form that can be stored, retrieved, and shared. From engraving on bones and Kipu's nuts to writing on paper, these are all examples of technologies that help humanity to store and share data. But data today is stored in digital form, and databases are the computer programs that help us store and retrieve this data. Once you have data, the next step is to organize it. Databases excel at structuring information in an efficient and accessible way. And a common method is to organize data into tables. For instance, you might have one table that lists clients with columns for name, age, and city, and each row represents a unique client, and each entry is assigned a unique identifier called a primary key. Now, let's say you have another table that has orders, and that table stores order numbers, the items purchased, and to know who placed each order, you would link records from this table to the records in the client's table using something called a foreign key. This key connects the 2 tables by referencing the client's unique identifier, allowing you to easily see who bought what. This structure is called a relational database. This is one of the most common ways to store and manage data, but this is not the only way of organizing data. I'll show you other methods towards the end of the video. Organizing data is just the start. The true power of a database lies in its ability to read and write data efficiently, like flipping through pages of a book to find the exact passage you need. This is where query languages come in, and the most common one is SQL, or Structured Query Language. So imagine you're searching for all the clients named John in your database. You'd write a query like select star from client where name equal John. It's just like asking for a librarian for a specific book. And of course, you can write queries to update, delete, and create new data. Now, storing and retrieving data may seem simple, but doing it efficiently and at scale is where things get even more complicated. Computers don't have infinite memory and resources, so databases have to be very smart. So they use techniques like indexes to quickly find information and caching to return frequently accessed data even faster. And another challenge arises when multiple users need to access or update a database at the same time. For example, if 2 users are trying to update the same piece of information, like changing the client's age. It's important to ensure that the data remains consistent and accurate. Databases handle this by managing simultaneous requests very carefully, using mechanisms such as read and write locks, transactions, rollback, and validation to ensure data is in a valid state. Many databases follow the ACID model, a set of principles that guarantee the reliability of these operations. These ensure the data stays reliable even when many users are reading and writing to the database at once. But as the amount of data grows, databases face the challenge of scaling. You can either add more resources to one machine, think of it as expanding an existing library to fit even more books, or you can distribute the data across multiple machines, like building more branches of the library. So with multiple machines, you can store copies of the same data on each one, and that's a technique called replication. Or you can split the data into smaller parts and distribute them across different machines, which is called sharding. It's like having copies of the same book in different libraries versus splitting the books based on topics and storing them in different libraries. Let's say science books in one library and history books in another library. Different databases have better scaling and distribution capabilities. For example, Redis is excellent for caching, while MongoDB is great at distributing data across multiple machines. However, scaling is not the only reason we have different types of databases. An accounting software and an AI-based system have vastly different needs when it comes to how they store and retrieve data. That's why there are many different types of databases, and each one is designed to solve specific problems in a unique way. We've already talked about relational databases, but there are also document databases, which are great for storing complex data as a whole document. You have key value stores, which are excellent for quick lookups using simple key value pairs. You have graph databases, which specialize in mapping relationships between data points. And you have time series databases, which are optimized for tracking data changes over time. And there are many more. And recently, vector databases have gained popularity, especially in machine learning applications, as they store data in a way that makes it easy to find similarities across large datasets. And even blockchain can be considered a type of database, offering a secure and decentralized way to store and retrieve information. As a developer, you need to understand at least one relational database such as PostgreSQL and one non-relational database, and you can watch this next video to learn about MongoDB, which is one of the most popular non-relational database on the market. It's a powerful tool that you'll definitely want in your developer toolbox.